Hey guys. All right. So I had a few people asking questions about this assignment, and I realized after teaching it in class for 2 class periods that I made a mistake on number 1A, and I think I made the same mistake in my last video. So I am going to go through and work one example. I'm going to do 1A, 2A, and 3A on here, and then I'm going to help you graph 2A in this video also. So hopefully this helps. If you have any questions after this video, then please email me and let me know where you're confused so I can help you more specifically, okay? All right, so on each of these, I'm wanting you to identify the vertex, the x-intercepts, and the y-intercepts. Okay, so on A, we are in standard form already, and when we're in standard form, we can identify our y-intercept. That's our C value. So my y-intercept is going to be 0, -3. All right. Then from here, we can go one of 2 ways. We can go ahead and factor and discover our x-intercepts, or we can complete the square and go to our vertex. So I'm going to go to our x-intercepts first. We can do one of 2 things here. I can use quadratic formula and figure out my x-intercepts, and you guys know how to use quadratic formula. So if you like quadratic formula, do quadratic formula. But I want to show you a different way to find your x-intercepts here, just so you have another option, another tool, okay? So the first thing I'm going to do, I want to use my x method, but to be able to use my x method, I really want my a value to be 1, so I don't have to do the whole box method. So what I'm going to do first is I'm going to factor out this 2. So 2x squared divided by 2 is x squared. Then I have 1x divided by 2. That's going to give me 1/2 x. Then I have -3 divided by 2. Well, that's just -3/2. Okay? All I've done is factor out the 2 from each piece. I factored out a 2. Okay? So I divided each piece by 2. If you don't like this method, you can use quadratic formula. I'm totally 100% okay with that. I'm just showing you a different way to Walmart, okay? All right. So now I can use my x method. My a value is 1. My a times c is -3/2. My b is 1/2. So I'm thinking about 2 numbers that multiply to give me -3/2 and add up to give me 1/2. And well, I know I can start with 1 times 3/2. 1 times 3/2 is +3/2. So one of these has to be negative. So I'm going to make this this one negative. I know the answer, so I'm trying to think about it the way you would think about it first. But then I have -1 plus, if I add these 2 together. So -1 times 3/2 does give me -3/2. And then let's add those. So that'd be -2/2 plus 3/2. Well, that would give me +1/2. And I have +1/2, so that's what I needed, right? -1, 3/2. So this factors to 2 times x minus 1 times x plus 3/2. Okay? If you use quadratic formula here, you would end up getting x equals 1 and x equals -3/2. Same thing. You would have gotten the same thing. So my x-intercepts are 1, 0, and -3/2, 0. Sorry, I'm writing it really tiny. Next, I want to go to vertex form. So I'm going to complete the square. I'm going to erase some of this so I have some room here. I'm going to use this complete the square where I have to do b over 2 squared. And in order to complete the square, my a value has to be 1, and we have to be in standard form. So I'm going to jump back to this form right here. So I'm going to jump back to 2 times x squared plus 1/2 x minus 3/2. Okay? So my a value is 1. We're in standard form. So I have b divided by 2 squared. So my b value here is 1/2. So I have 1/2 divided by 2 squared. Well, if I keep it, change it, flip it, keep it, change it, flip it, right? I'm multiplying fractions, multiply by the reciprocal. Dividing fractions, and that means I'm multiplying by the reciprocal. So that becomes 1/4, and I'm still squaring that. So that's 1/16. So when I complete the square, I'm changing my trinomial to be able to make it a perfect square. So I have 2 times x squared plus 1/2 x. Then I'm going to add in my 1/16 here. So there's my, let me change this to a different color. There's my trinomial that I'm going to complete the square with. But I can't just, that's supposed to be a 16. There we go. I can't just add 1/16. So I also, because that changes my equation, okay? So essentially I want to add 0, and I'm going to do that by adding 1/16 and then immediately subtracting 1/16 at the same time. And then I still have minus 3/2. Okay, so this orange part is the part that I'm going to factor to the perfect square. I'm going to just kind of erase that. And that's going to look like x, and then I'm going to have a number here that I'm multiplying by itself to get 1/16. So if I do my x, a times c is 1/16, b is 1/2. So what number did I multiply by itself, because it's squared, what number did I multiply by itself to get 1/16? But if I add it to itself, I would end up getting 1/2. Well, here's a little hint. It's always going to be this number right here. So it's 1/4. 1/4 times 1/4 is 1/16. 1/4 plus 1/4 is 2/4, which is 1/2. So we would have 1 plus 1/4. Okay. Then we have -16 minus 3/2. Well, -1/16 minus 3/2 is the same thing as 24/16 if I multiply both those by 8. So that gives me -25/16. So I have minus 25/16. All right, so I'm not quite in vertex form yet because I have this extra set of parentheses. So I need to deal with that. I'm going to go ahead and distribute this 2 to both terms. I only have 2 terms here. I have this term that's being squared, and then I have this term over here. So I'm multiplying both of these terms by 2. So I'm going to have 2 times the first term, which is x squared, x plus 1/4 squared. And then I have 2 times 25/16, which I think you guys are all going to look at this and think 50/16, which then simplifies to 25/8. So we have minus 25/8. My vertex is, let me get a different color here. My vertex is the opposite of h. So I take the opposite symbol there. So the opposite of positive is negative. H is 1/4. And my k value. So -25/8. So I just take my k value as it is, -25/8. Okay? All right, if you have any questions about this, then let me know. Let me know. I will be more than happy to do this again using quadratic formula if you want me to. All right, so here we go again. We're going to change it. We're going to use red now. We want to identify our vertex, our x-intercepts, and our y-intercepts. So right now we are in vertex form. So my vertex is the opposite of h and k. So the opposite of h is negative, and opposite of positive is -1, and my k value is -3. Now I want to move to standard form. Standard form is a nice place to go in the middle because you know how to work with standard form. You know how to factor from standard form, and you know how to complete the square from standard form. So I'm going to go to standard form, but in order to get there, I have to deal with this exponent. So I have -2 times x plus 1 squared means I'm multiplying it by itself, right? So don't look at that and say, oh, well, that's x squared plus 1. That's not true, and I'm going to show you why in just a second. okay? So now I'm going to multiply my two binomials together by distributing. So x times x, I have negative 2. X times x is x squared. X times 1 is x. 1 times x is x. 1 times 1 is 1. And I still have a minus 3. Then if I combine my terms here, then I have negative 2 times x squared plus 2x plus 1. And then we still have this minus 3. So do we see how this is very different than this, right? Don't just look at something squared and say, well, that's x squared plus 1. That would be x times x and 1 times 1. That's not true. We have this middle term right here that changes things. Okay, so be really careful doing this. Oh, I didn't mean to do all that. Okay, there we go. Okay, so now I can distribute my negative 2 through. So we have negative 2x squared. Negative 2 times 2x is minus 4x. Negative 2 times 1 is negative 2 minus 3. Got some like terms I can combine here. So I have negative 2x squared minus 4x minus 5. So I can identify my y-intercept. My c value is 0, negative 5. Remember, your y-intercept is always, the x value is always 0 because you're on the y-axis. It's where you cross the y-axis. My x value on my y-axis, no matter where I'm at, is 0. Okay? Okay, so now we could factor out this negative 2 like we did in the problem above, but I want to go to quadratic formula. And really, I'm going to start with, instead of doing the entire quadratic formula, I'm going to start with just my discriminant. So if you remember, your discriminant is the b squared minus 4 times a times c, which is the part that's underneath the square root. And that tells us if we have two real x-intercepts, two non-real x-intercepts, two real solutions, two non-real solutions, or one real solution, based on if it's 0, a positive number, or a negative number. So this is helpful because if we have two solutions, two real solutions, that means I'm crossing my x-axis twice. If I have one real solution, that means I'm crossing my x-axis once. If I have two non-real solutions, that means I'm not going to touch the x-axis, so I don't have any x-intercepts. Okay? So this can help us know how many x-intercepts am I actually looking for. Okay? So I'm going to start with using my discriminant. So my b value is negative 4, so I have negative 4 squared minus 4 times a is negative 2 times c is negative 5. So negative 4 squared is 16. Negative 4 times negative 2 is positive 8 times negative 5 is negative 40. And this is some negative number, right? At this point, I don't really care what negative number it is. It's a negative number. That means I have two non-real solutions. So I don't cross the x-axis. So I have no x-intercepts. Okay? All right, so then number 3a. Again, if you have any questions, please let me know. I'm more than happy to work some of these problems again, okay? All right, so now we have equations in intercept form. We're still going to identify our vertex, our x-intercepts, and our y-intercepts. So we're in intercept form. We can identify our x-intercepts. We have, remember, we're taking the opposite sign. So we have negative 3, 0, and opposite sign, 1, 0. Like I said before, it's easy to go to standard form in between each, in the middle, because we know how to work with standard form. So we have x times x is x squared. X times negative 1 is negative x. 3 times x is 3x. 3 times negative 1 is negative 3. Combine our like terms. So we have x squared. Negative x plus 3x is positive 2x. Then we can distribute this 2. So we have 2x squared plus 4x minus 6. And my y-intercept is 0, negative 6. So in order to get to vertex form, our a value has to be 1. So I'm going to back it up to this form here. I'm going to factor out that 2. So our a value is 1. I'm going to do b over 2 squared. So I have 2 over 2 squared, which is 1. 2 over 2 is 1. 1 squared is still 1. So I'm going to do 2 times x squared plus 2x plus 1. I'm going to immediately subtract 1 so that I essentially added 0, minus 3. So then I'm going to factor this part right here, okay? So what two numbers multiply to give me 1, add up to give me 2? Well, that's 1 and 1. So I would do x plus 1 times x plus 1, which is the same thing as x plus 1 squared. Then I've got some like terms I can combine here, negative 4. I have this extra set of parentheses I need to deal with, so I'm going to distribute this 2 through, and that's going to give me 2 times x plus 1 squared, and 2 times negative 4 is negative 8. So my vertex is opposite of h, which is negative 1, and my k value is negative 8. Okay? All right, so let's see, I've got my stuff here. Oh, I forgot I left this on here. Don't look at it. I'm going to do all this with you in just a second. Okay. All right. So we know from 2a that our vertex is negative 1, negative 3. We know that our y-intercept is 0, negative 5. And we know that we didn't have any x-intercepts. So there's a few things I'm asking you to find. Are we opening up or down? So my equation is f of x equals negative 2 times x plus 1 squared minus 3. In Algebra 1, we learned that if my a value is negative, then my equation opens down. If it's positive, it opens up. So this is going to open down. Since it opens down, it's going to look like this. My vertex is going to be a maximum. So we got direction of opening. We answered if it's maximum or minimum. And we have an axis of symmetry. So the axis of symmetry, okay, so sorry, I got interrupted. Our axis of symmetry was x equals, it's always x equals, and it's always the x value of our vertex, so that's x equals negative 1, okay? All right, so there's our axis of symmetry. So the next thing I'm going to do is I'm going to graph my line. So I have a couple points already. Let me erase this, we don't need that. I have my vertex is negative 1, negative 3, so negative 1, 1, 2, 3, negative 3. I have a y-intercept is 0, negative 5, 1, 2, 3, 4, 5. But in order to graph a parabola, I have to have 3 points. So I'm just going to pick an x value on this side of my vertex. So I'm going to choose, we have negative 1, we have a 0. I'm going to choose negative 2. And I'm going to plug that into my equation. So I'm going to do f of negative 2. So negative 2 times, instead of x, I'm doing negative 2 plus 1 squared minus 3. So I do the stuff inside my parentheses first. So negative 2 times negative 2 plus 1 is negative 1 squared. So negative 1 squared, I have negative 2. Negative 1 squared is 1. Negative 2 times 1 is negative 2 minus 3, which is negative 5. So I would have a second point at negative 2, negative 5. That means when x is negative 2, when I plugged in negative 2 for x, my y value is negative 5. So negative 2, 1, 2, 3, 4, and 5. Since I have 3 points, I can go ahead and connect those. Doesn't have to be perfect. We've got them connected. Okay, so now we have, I want to identify the intervals for which the function is positive or negative. So positive is when we are above the x-axis. Well, for this graph, we're never above the x-axis, so we don't have an interval where we're positive. If it's negative, that means we're below the x-axis. So for what x values are we below the x-axis? Well, I'm below the x-axis for my whole graph. So from negative infinity to positive infinity, I'm going to be below the x-axis. Then we have a section of our graph where we're increasing, and where does that happen? So I'm going to start on the left-hand side of my graph from my arrow, and I'm going to move along my line. I'm increasing, I'm moving up. And at one point, at a certain point, whoops, I didn't mean for that to become a straight line. At a certain point, I change directions, and that point is my vertex. So I'll be increasing from negative infinity, my x values, I'm talking about my x values here. So my x values, I'm increasing from negative infinity all the way to my vertex, and my x value of my vertex is -1. And then I'm decreasing. At my vertex, I change directions, and I start going down. And I'll just keep going down forever and ever and ever and ever and ever, right? So at -1, I change directions, and I'll be going down until positive infinity, okay? All right, so there's some examples. If you have any more questions, please let me know. I hope this helped, but if you have questions, that's totally 100% fine. Send me an email of the question you're having or where you're confused so I can address that specifically. Don't just say, hey, I don't understand, okay? Give me some specifics so I can help you. All right, if we need to video chat, I'm totally okay with that. Just send me an email. I will see you guys.